students, welcome you all for speed maths based on Vedic sutras. Today we'll see a sutra called Ekadikena Purvena. Ekadikena Purvena. Okay. The technical meaning of the Ekadikena Purvena is Eka, that is one, that is Adhika, that is to be added, that is Purvena, to the previous digit. So 1 to be added to the previous digit, or 1 to be added, or 1 is more than the prior number. So 1 to be added to the previous. It's a literal meaning of Ekadikena Purvena. So we should see how it will help in multiplication of 2 digit, 3 digit, 4 digits. Okay. Here there are some situations we have to follow in case of multiplication for using this Ekadikena Purvena. Situation number 1 here, situation number 1. Okay. The situation number 1 is the sum of the last 2 digit, the sum of the last digit, okay, or digits of multiplier and multiplicand should be equal to 10, either 10, 100, 1000 and so on. Okay, this is foremost situation number 1. And one more situation is situation number 2. Okay, the situation number 2 is the prior digit should be the same. In case of 2 digit multiplication, there are 2 terms. One is multiplier and one more is multiplicand. Say for example 23 into 27. Okay, we have here the prior digit of 23, that is 23. If the number is 23 into 27, then prior digit of 23 is 2, and in multiplier is 2 and multiplicand is also 2, that is the same digit, and the last digit, that is the 3 and the 7 of multiplier and multiplicand should be equal to 10. So we will see here 2 is the same in multiplier and multiplicand. And 3 plus 7 which equal to 10. Here we have 2 situations made out. That is the sum of the last digit, digits of a multiplier and multiplicand equal to 10, and the prior digit, that is 2 and 2, that is same. In this case only we can utilize this Ekadikena Purvena and solve the sum, that is 23 into 27 which is equal to, so 23 and 27, so which is equal to, see, 2 and 3, we should multiply the unit places. 3 and 2 is 21, forming RHS. Okay, this is RHS side. Next, we have to add here the 1 to be added to the previous digit, which Ekadikena Purvena says. So we have to add to the previous digit, that is the previous or the prior digit here is 2. We should add 1 here. 1 to be added to the previous digit, that becomes 3. 3 should be multiplied back to the 2. So 3 2s are 6, forming LHS. Okay, here there are two parts. So 6 and 21. The answer here is 621. Okay. We'll see now few more examples. Example 34 into 36. So here 34 is a multiplier, 36 is a multiplier. If you consider here 34 and 36, 3 is the prior digit of 34. Okay, 3 is a prior digit of 36. Next 4 is in tens place, unit place, and 6 is in unit place. The sum of the last digit of 34 and 36, which equals to 10. That is 4 plus 6 is equal to 10. So which meets our first requirement, first situation requirement is the sum of the last digit equal to 10. And the other digit, that is 3, is same here. In this condition we can utilize this ekadikena purvena, that is 1 to be added to the previous digit, and solve this multiplication. Here we have to add here, that is 1 to be added here. 1 should be added to the previous digit, that is 3. 3 plus 1 is 4, and it should be multiplied back to the 3. We get LHS, that is 12. 3 4s are 12, forming LHS. Okay. Next here is 4 and 6 to be multiplied and form RHS, that is 4 6 are 24. Okay, we should join this LHS and RHS, forming the answer. The answer here is 12 24. That is 1424 is the answer for 34 and 36. Okay. Now we'll see 3-digit multiplications. Example 126 into 124. We'll see the situation here. The last digit of the multiplier and multiplicand, that is 6 and 4. 6 plus 4 is equal to 10. So it meets the first requirement, that is the sum of the last two digits equal to 10. Now the other digits, that is a prior digit of 126 and 124, which is 12. It is same here in multiplier and same here in multiplier. That is, in this case what we have to do with the solution here is 1 to be added to the previous digit, that is 1 to be added to 12, which forms 13. This 13 to be multiplied back to 12, and now the answer here is 156, that is forming LHS. Okay, now this is forming LHS. Here 13 and 12. 13 into 12 is 156. We form this 156 as LHS. And one more is 6 and 4. 6 into 4 is 24, forming RHS. So now we join both LHS and RHS, forming the answer 15,624 is the answer for 126 into 124. Okay. We'll see now one more example, that is 3-digit multiplications. Example 650 into 650. Okay, 650 into 650. Now we'll see the multiplier and the multiplication, whether the situations of a ekadikena purvena applies here or not. Here 50, the last digits of the multiplier and the multiplicand equal to what? See, we'll see here the last two digits. So 50 plus 50, which equals to 100. Our first situation in case of ekadikena purvana is the last digits of multiplier and multiplicand, either it should be 10 or it should be 100. Here it meets the requirement of ekadikena purvana, which equals to 100. Now the other digits of the multiplier and the multiplicand, which is the same, that is 6. What in this case what I have to do is here, so 50 into 50, we'll have to multiply and form RHS. That is 50 into 50 is 2500 and forming RHS. Okay. Next, this other digit is 6. What I have to do is based on the ekadikena purvena is that is 1 to be added to the previous digit, that is 1 should be added to 6. So that forms 7 which should be multiplied back to 6, that will form LHS. Here LHS is 6 into 7 is 42. The one more information here is I want to pass on here is if the last digits of multiplier and multiplicand which should be equal to 10, in that case the RHS should have 2 digits. But here we have 100 is there, that is 50 plus 50 which equal to 100. The last digits of a multiplier and multiplicand which should be equal to 100. Here in case of 100 the sum of the last 2 digits. So we have to have 4 digits in case of RHS. See, we have 4 digits here, 1, 2, 3, 4. And in LHS there is no such condition. See, 42, 6, 7 is 42. Now what I have to do is, so we'll have to join 4, 2, 2, 5, 0, 0 is the answer. Okay. Now we look into 5-digit multiplication. Example, we'll take up initially 11,500 into 11,500. First we have to see the multiplier and the multiplicand whether the situations of ekadikena purvena meets out or not. Here we have 500, here we have 500. The last 3 digits of multiplier and the multiplicand, what it should be equal to, that is 500 plus 500 is equal to 1000. Our first situation in case of ekadikena purvena here is the last digit or digits of multiplier and multiplicand, if it is equal to 100, if it is equal to 10, if it is equal to 1000, so we can use the ekadikena purvena. The other digit, that is 11, the other digit, that is 11. 11 in case of multiplier, 11 in case of multiplicand, it is same. In that case, what we have to do for solving this, 1 to be added to the previous digit, that is 11. So it forms 12. This 12 to be intermultiplied by 11 which forms 132 as LHS. Okay. Next, we have 500 and 500. 500 multiplied by 500 is, you can simply just 5 5s are 25. So double 2 zeros plus 2 zeros which equals to 1, 2, 3, 4. Here the condition for if the last digit, the sum of the last 2 digits which equal to 1000, RHS we should contain RHS, we should have 6 digits in RHS, that is 1, 2, 3, 4, 5, 6, and in LHS there is no such conditions. Okay. Here what I have to do is I have to join these two LHS and RHS forming the answer. The answer for 11,500 multiplied by 11,500 equals to 132, 25, 1, 2, 3, 4. That is, you need tens, 100, 1000, 10,000, 1 lakh, 10 lakh. Okay, 1 crore. That is 13 crores, 22 lakhs, 50,000 is the answer. Understood? It is very easy to use ekadikena purvena in such situation and forming very easy answer for multiplications of 2 digit, 3 digit, 4 digit, even 5 digits and more than 5 digit also. But only thing is we have to identify the situations of the multiplier and multiplier. That's all.